All right, so in the last video, I explained how you can come up with an ellipse equation just by thinking about transforming a unit circle by stretching it vertically and horizontally and then shifting it vertically and horizontally somehow. So in that video, I came up with this equation right here, where you have the divided by a and the divided by b is stretching it by a factor of a and b horizontally and then vertically. You can tell horizontally because it's dealing with x and vertically because it's dealing with y. So just remember which axis is which. And then the shifting comes from subtracting a number from x and subtracting a number from y. And you can remember subtract a negative number if you want to shift it to the left, or subtract a positive number to shift it to the right, at least horizontally. Down and up for vertical. So that's the equation, but the equation format you'll see most often is actually this one, where the squaring is distributed across the division. So we have the numerator squared and the denominator squared. That gives us this a squared and b squared down here. Interestingly, if a and b are equal to each other, say the a and b are both equal to the same number, like 2, then you'll have divided by 4 and divided by 4, and you can just multiply both sides of this equation by 4 and then get equals 4 on the right, which is the equation of a circle. So if you make an ellipse by scaling by exactly the same values in the vertical and horizontal directions, you have a symmetrical ellipse, which is a circle, and then the equation reduces back to equals r squared. So I just wanted to point that out because I think it's a nice idea. It just tells us that a circle is really just a special case of an ellipse where the a and the b values are equal to each other. So in this equation, remember the center, the very center of the ellipse is going to be the point hk, given by those values, and then the a and the b are telling us sort of the horizontal radius and the vertical radius. I do this because radius is not really the correct term to use there, but it kind of gives you the gist, right? It's the half length of it's half the length of the ellipse measured from one side to the other. In either the horizontal direction or the vertical direction. We're not going to be dealing with tilted ellipses in this class. That is a thing that you can do, but it requires trigonometry. So maybe if we have time, we can come back and look at tilting axes later in this class, but it will not be today. So let's look at an example. Over here we have an ellipse that I've drawn, kind of not a great ellipse, but whatever. I'm hard on myself with drawing because I like drawing anyway. Sometimes I don't do a great job. That's fine. It's an ellipse. And I've got these sort of extreme points labeled. So we can see it comes all the way out to this point, negative 3, 2, and all the way out here to 9, 2. The distance between these points, if we cut that in half, will give us the a value. So let's see. From negative 3 to 9 is 12 units, which means that a should be 6. So here I'm going to write a equals 6. That's the first thing we've found. Look at the vertical direction here. You see these are both at x equals 3, which is good. They're on a vertical line. The distance between them is 6 units, from 5 to negative 1. Cut that in half, and we'll find the b value. So we'll see b equals 3. So if I plot a point right at the center right here, which is halfway between here and halfway between here and here, these distances, that's my 6, and that's my 3, right? But the coordinates of this point should be the center point, and they'll be h and k. So let's see. Those are going to be 3 and 2. So I've got hk is going to equal 3, 2. And that's all I need to do. I just need to grab that information from the graph, and then I can use that to make my equation. So that will be x minus 3, because 3 is the x coordinate of the center, and then divided by a squared. So a is 6, so that's going to be 36, plus, and then y minus the 2 squared over b squared. B was 3, so I'm going to do over 9, and then it's always equals 1. And that's my equation for that ellipse. This ellipse is oriented horizontally. We call it oriented horizontally because it's what's called the major axis, which is the longer of the two, quote, diameters, like the vertical and horizontal diameters. The longer one is the major axis, and the shorter one is the minor axis. And Sometimes some textbooks will have A always represent half the length of the major axis, which, if it's oriented horizontally, might actually be the vertical distance. Honestly, I forgot what our textbook does. I'm going to have to check on that and let you know. But double check the textbook for how it defines A. And it's either going to be always horizontal or it's always the bigger of the two values. And it can be a little annoying when you kind of swap back and forth between those. But so far I have presented this as if A is always the horizontal scaling factor. But just be careful. Some textbooks will swap the A and the B when it's oriented vertically like this. So A and B. Okay, it's not that bad. It's a little annoying, but it's just a little bit of a slight adjustment in the letters you're using to represent things.